The last section in Unit 10 is titled Powers of Monomials. So again, we're still in our same standard 8NS3 because we're learning to apply all the properties of exponents. So let's do a quick review. Remember, when you're asked to simplify, you just need to combine any monomials or that have like bases. So in number 1 we have 8 to the second times 8 to the fifth. What we'll do here is, because we have the same base, we add the exponents. So this becomes a to the 7th. Can't do any further simplifying, so that's our answer. Number 2, now we have division. So remember, with division we're going to subtract exponents. So c to the 9th divided by c to the 4th is c to the 5th. So that's just a quick review of what we've done over the last few units. That will also help today. So the first property I need you to write down is called the power to a power property. What this says is that to find a power raised to another power, you will multiply the exponents. Excuse me. So for example, we have a to the m power, and that's all being raised to the n power. So in this case, we're going to do m times n. In the examples down the bottom, you can see that 6 to the 7th power to the 9th power, you multiply 7 times 9, so 6 to the 63rd power. We also have 2 squared to the 4th power, and that's 2 to the 8th, because 2 times 4 is 8. This one I will expand out for you so that you can see why it works. So remember that if we have something being raised to the 4th power, it means that there are 4 of them. So what's being raised to the 4th power? 2 squared. So this is 2 squared times 2 squared times 2 squared times 2 squared. Now we learned, and we just reviewed, that if you're multiplying like bases, you add exponents. 2 plus 2 plus 2 plus 2 is 2 to the 8th. And we can take this one step further. All of these 2 squareds are 2 times 2. So it's 2 times 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 2. Now if we count all the 2's, 1, 2, 3, 4, 5, 6, 7, 8, 2 to the 8th power. So instead of having to expand it all out and figure it out, we know that you can multiply exponents when you have a power to a power. So let's look at some examples. Here I just want you to simplify. We aren't going to actually evaluate. So for example, on number 3 we have 9 to the 6th power squared. We'll multiply exponents and get 9 to the 12th. We're not going to evaluate that. That number is humongous. Probably wouldn't fit in your calculator. Number 4, we have a variable, q to the 4th to the 5th power. So we're going to multiply 4 times 5 and get q to the 20th. Negatives work the same way, so go ahead and multiply first. 4 to the 3rd power, all raised to the negative 7th. So 3 times negative 7 is 4 to the negative 21st. We did learn in our negative exponent lesson that you cannot leave an expression or a monomial with negative exponents. So we do need to correct that. Remember how we fix negative exponents. You move it into a denominator and put it under 1 if there's nothing else with it. So this becomes 1 over 4 to the 21st. Again, we aren't going to evaluate 4 to the 21st power because it would be a humongous denominator and actually would make a very small fraction. The next rule is called the power of a product. So this says if you have a product, which remember is a multiplication, raised to a power, then everything inside the parentheses essentially is going to be raised to that power. So if we have a times b in parentheses and it's all being raised to the m power, that's the same as saying a to the m and b to the m. Oftentimes students like to call this distributing, and I don't want you to get confused. We are not distributing the exponent, because distribution is more of a multiplication process when you multiply something inside of parentheses. But it's kind of that idea where everything inside gets that exponent. So the examples on the bottom, we have 2 times 4, so that's what we're multiplying, and it's all being raised to the third power. So that's the same as saying 2 to the third times 4 to the third. And then you can see I expand this out further down here. 2 to the third is 8, 4 to the third is 64, and 8 times 64 is 512. You can also do it with variables when you have a coefficient. So if we have 4x in parentheses and it's all being squared, it means the 4 is being squared and the x is being squared. Well, 4 squared is 16. X squared is x squared, so the expression becomes 16x squared. Let's look at some more examples. So I get pretty complicated right off the bat, so that I think that by doing it this way you can see a little bit better how it really works. So in the parentheses we have 5r to the 7th. I can't simplify anything in there. I can't do anything. That's just 5r to the 7th. But now I'm squaring all of it. So remember, that means you're squaring the 5 and you're squaring r to the 7th. Now I'm really going to break this down for you. So we're squaring 5 and we're squaring r to the 7th. But we need to keep simplifying. So 5 squared is 25. And remember the power to a power property we learned earlier in the lesson. If I have a power raised to a power, I multiply the exponents. So this becomes r to the 14th. So we squared the 5 and got 25. We squared the r to the 7th and got r to the 14th. Remember, this is very different than what we were doing previously, where we were adding and subtracting exponents. Now we're multiplying them. So on example 7, we have 2x to the 6y cubed, and it's all being raised to the 4th power. So everything is getting this 4th power. And I like to write it out initially till I really kind of understand what's happening. So we have 2 to the 4th power times, we have x to the 6th power being raised to the 4th power, and we have y to the 3rd power being raised to the 4th power. So now when we simplify, 2 to the 4th, that's 2 times 2 times 2 times 2, so that's 16. Again, we're going to be multiplying exponents. We have a power raised to a power, so that's x to the 24th, y to the 12th, 3 times 4. If you'd like to pause the video here and try this next one on your own, negative 4 s to the 5th, t to the 7th, and it's all being raised to the 3rd power. So everything gets the 3rd power. Be very careful with your negative here. We want to put that negative 4 in parentheses. So negative 4 to the 3rd power. We have s to the 5th to the 3rd power. And we have t to the 7th to the 3rd power. Now when we simplify, negative 4 times negative 4 is positive 16. 16 times negative 4, because remember this is negative 4 times negative 4 times negative 4. That's negative 64. S to the 5th to the 3rd is s to the 15th. And t to the 7th to the 3rd is t to the 21st. Remember, when you get through the simplification process, if you have any exponents that are negative, you'll need to take care of those by putting them in the bottom and making them positive, or putting them in the denominator and making them positive. So that's it for the video. We will work on a worksheet to review the topic when we return to school.